science.org. Today we'll be talking a little bit more about half-life. Got two problems up here, kind of two typical half-life problems you may run into, you may encounter. I'm going to show you how I kind of encourage you to work through it. There's a formula for half-life for more advanced half-life problems than what we deal with here with in physical science. So just kind of want to base this on just thinking, problem solving, critical thinking skills, just thinking about what's given to you, and you can figure it out with any math formula. As long as you understand the terms, as long as you understand what is half-life, as long as you understand what is nuclear decay or radioactive isotopes. And if you don't, check out some of the videos posted prior to this one and explain some of those concepts. We're going to jump right in here to this one. So we're going to look right here at number one, and then we'll go a little bit more in depth with number two, a couple things you could do. Number one, so I don't know how well you can read this, says a sample of radioactive isotope with a mass of 8 grams decays to 1 gram. It took 18 days to decay. What is the half-life? So here we got a sample that's decaying, and we know a starting point where it decayed, which was 8 grams, and we know a stopping point. And it didn't really stop there, it kept going, but we're just saying during our time frame we're looking at for this question, we have a start and an end. We have 18 grams start, we have a 1 gram end. This time it took, the time it took to do this is 18 days. So we have some stuff we can work with, we can figure out. We know half-life describes a radioactive isotope that's decaying. And it's decaying continuously, where half-life specifically focuses on the amount of time it took for it to decay from whatever starting point you're at to half of that, and then half of that, and then half of that, and so forth and so on. It'll always be the same. So if we went from 8 grams to 1 gram, all right, we'll start with 8 grams. First thing, how many times you got to half 8 to get to 1? All right, so we're going to go ahead and we're going to half 8 right here one time. Half of 8 is 4. Then we're going, that ain't 1, so we're going to go ahead and we're going to half it again. That's 2. We'll have it again, and that's 1. So what you should see here is we halved it 1, 2, 3 times. All right, so 8, it went through 3 half-lives. 8 to 4, 1 half-life. 4 to 2, another half-life. We're at 2 now. Then 2 down to 1, that's our third half-life, so it took 3 half-lives to get here. All right, so we know right now it took 3 half-lives. 3 half-lives to get there. How long did this take? 18 days. All right. So there are 3 half-lives. There are 3 packets of time within this 18 days in which our sample went through a half-life. So you just kind of got to figure out how long is a packet of time? Right? Is it 5? Right. So if the half-life was 5 days, then we would have to do it at 5 days. We'd have to do it at 10 days. We'd have to do it at 15 days. So no, it's not. It's not 5. All right. So maybe 6. All right. So after 6 days, it would have reduced, or it would decayed by half. After 12 days, it would decay by half. And then after 18 days, it would decay by another half. So that's 3 half-lives there in that time period, which is what we witnessed. All right. So that means that our half-life must be 6 days. I hope that kind of helped make sense of that. All right, moving on. Here we got radon-222 is a naturally occurring isotope with a half-life of 3.8 days. I know we got a little glare going on, looks like. If 4.0 grams of radon-222 gas were to decay for 7.6 days, how much radon-222 would be remaining? Something my students have trouble with is this 222. And if y'all are watching this, y'all know that's true. We see 222, 222, 222 over and over again. We got more numbers in there. It's making it more complicated to figure out what do I do with each. All right, so if you watched the previous video, you know that this number after the name is just the mass of the isotope. It's the mass of one single isotope of radon. It has nothing to do with our sample size. Our sample size could be 1 billion metric tons of radon. This number would still be 222 because it's just describing us which isotope of radon are we using. It's pointless other than that, right? Unless you want to calculate neutrons, which does not say anything about calculating neutrons in there, so that's not what we're doing. So this is just an identifying feature that we are going to ignore. So, first name, last name. Radon 222, first name, last name. Just don't worry about it. First name, last name, don't worry about it. First name, last name, don't worry about it. While we're in here working on this radon, we're going to be on a first name basis. So we ain't worried about this. All right? We don't need it. Okay? If it's causing you confusion, get rid of it. Right? Eventually you'll understand that you don't need it and you'll be able to work with it still there. So what we do need, right? Radon is a naturally occurring isotope with a half-life of 3.8 days. So every 3.8 days, half of that has decayed and is no longer there. If 4.0 grams of radon were to decay for 7.6 days, how much radon would be remaining? So it's going to go through decay for 7.6 days. It takes 3.8 days per half-life. So it's going to go through a complete half-life cycle twice. All right, so we get that from 3.8 days per half-life, 7.6 days total. All right, this means we're going to go through 2 half-lives. Right. We started with 4.0 grams. So we're just going to take 4. We're going to go through 2 half-lives with it. We're just going to half 4 2 times. 4 down to 2 is 1 half. Half it again because the second half-life, we're down to 1 gram. So our answer for this is 1 gram. I'll take just a second. If it asked us for a percent, or if it asked us for a fraction, we could also answer it that way as well. So if we're talking about percent, when we're starting with a sample, it could be a 4 gram sample, 18 gram sample, a 1,000,000 gram sample, a 4 billion metric ton sample. Whatever sample we're starting with, that is 100% of our sample. We're not starting with a fraction already, right? Whatever we have is what we have to start with, right? Some people start off with more money than others, but whatever we got is 100% of our money, right? That's where we're starting at. So we're always going to start at 100% when we're dealing with fractions. And that's specifically outlined for you that you're not having 100%. So something would already had to occur. But in general, we're going to start with 100%. So we got 100%, and we're going to go through 2 half-lives. After 1 half-life, we're at 50%. After another half-life, 25%. So after 2 half-lives, there's 25% left, or 1 gram, right? 25% of 4 grams is 1 gram. Kind of the last one I wanted to hit real quick is a fraction. I'll kind of slide over here. So for a fraction, 1 over 1 or 1 is our 100%, is our starting point. So you can start 1 or 1 over 1. Kind of whatever makes sense to you in your head is fine. We're going to send it through a half-life. After 1 half-life, we're at half. Right? After another half-life, we have half of a half remaining, which is a fourth. So we have 1/4 of our original sample. Something you may not be aware of, just kind of a little trick. If you're doing fractions, right, you start with 1. So half of 1 is half. Half of a half is a quarter. Half of a quarter, an eighth. Half of an eighth, a 16th. Half of a 16th, a 32nd. Then a 64th. Then 1/28. Then a 2/56. And then a 5/12. And then a 1,024. If you hadn't hit on to that, when you're taking half of a half, half of a quarter, so this kind of trend here, we're just doubling our denominator. All right, we're just separating that thing, we're halving it into equal pieces. We're going to double that denominator down. So I hope this is helpful. I hope this allowed you to see kind of how to work through and think through some of these half-life problems without a fancy formula. You ain't got to deal with no logs, none of that. Not many people like dealing with those. So let me know if I missed anything, or if you have a question or a problem you want me to help you work through, I'll give it a go.